Today's topic is forecasting. Forecasting can be done in Excel as well as Tableau. For more options and an in-depth analysis, Tableau would be the better option, which we will be demonstrating today. First, let's go over what forecasting is. Forecasting is a method of using historic data to determine the direction of future trends. They help companies estimate for the future and build a plan. It is important to remember that forecasting is not a prediction. It is based on traceable and observable data as opposed to assumptions. For example, managers in the supply chain use forecasts to make production and logistical plans, and the marketing industry uses forecasts to determine which products and services to introduce or discontinue. Now let's get started with the tutorial.
The datasheet that we will be working with today can be found on Tableau's website. In order to perform forecasting in Tableau, we will need a date field and a measure. In this case, we will use order date under year, and we'll also use a secondary order date. By right-clicking on quarter, we could actually change that quarter into a monthly unit. The measure that we will be using is sales. Then from the Analytics tab, we will drag out forecasts to the dataset. Tableau will have forecast prediction interval and shaded band by default. You may also change the mark type by clicking on this tab to alter the way the prediction interval is displayed. When using forecast in Tableau, the model selection is automatic, but there are a few things in our control that we may be able to adjust. If we want to customize the default forecast, we can begin that process by right-clicking on the sheet, selecting Forecast, then selecting Forecast Options. In Forecast Options, we can alter the forecast length. Forecast length sets the length of time into the future the forecast will extend. Leaving the option as auto will have Tableau automatically pick the forecast length. Picking exactly specifies the forecast based on the number of units, which you can select either by quarters, months, weeks, days, hours, and so on and so forth. Choosing until will extend the forecast to a specified point in the future. We will leave it at auto. Source data is good to use when there's a portion of data missing. For example, if we're trying to create a forecast while we're midway through a cycle, this is what we would use. We would trim the data missing to last complete data set. By default, Tableau ignores the last unit of aggregation, regardless of whether it's a unit of months, quarters, or other measurements. Right now it's automatic to months. The forecast model option can be automatic without seasonality, which leaves forecasting up to Tableau, and custom. When selecting custom, two additional options will appear: trend and season, which both can be set to none, additive, and multiplicative. The last forecast option that can be altered is the prediction interval. The shaded area represents the range of values for the forecast with a 95% confidence. This means that based upon the statistical value, there's a 5% chance the future value will be outside of our forecast. The higher the percentage in prediction intervals, the wider the shaded area will be in this area. Next, we will learn more about the information describing the forecast. In this datasheet, we are presented with the forecasts of sales across different priorities. We begin by right-clicking on the datasheet, going to Forecasts, and selecting Describe Forecasts. We are presented with two tabs, the Summary View tab and the Model tab. In the Summary tab, we are presented with the following information: time series, the measures that was used, how far the forecast dates go, and the dates that the forecast was based upon, what was ignored, and if there was a seasonal pattern is also included. Also in the Summary tab, we get more information about the measure we use specifically. The table is broken out by dimensions in the view. Looking at the contribution and season, we can see that there are two order parties that do not have seasonality in their data. In addition, taking a look at quality indicates how well the forecast fits into the existing data. The second tab at the top, which is models, describes the metrics and smoothing coefficients used in the model. Tableau does not allow users to alter the smoothing constant, but Tableau already automates that functionality. Next, we will explore forecast field results. We will use a datasheet showing an existing forecast for profits. First, we will click a measure that has been forecasted, in this case, profit. Then we will select forecast results. We will be presented with several options. First, we will begin by dragging profits into tooltips. We will right-click to pull up the menu, and then we will go to forecast results, and we will choose precision. Next, we will click on tooltip to edit it. We begin by typing forecast precision, and then we will insert it by selecting precision of sum for profit. We will then click OK, and now we can hover over the forecast and we will be presented with a plus and minus that indicates the size of the prediction interval, which is based on the confidence that we've used. In this case, we use 95%. In order to forecast in Tableau, there are requirements that must be met. The data being forecast needs at least one date and one measure, at least 5 data points, and if the data is seasonal, then there must be 2 seasons worth of data. To summarize what we went over, we learned the requirements needed to create a forecast. We learned how to use a measure and a date field to create a forecast. We also examined the forecasting options and how we use it to alter the data shown to us. And we covered the summary and how to describe the data, in addition to using the precision tooltip to display plus and minuses for forecast precision. Thank you for watching.